Good morning, Aksharians. Now we will move on to the next problem in arithmetic chapter exercise 1.3. That is problem number 18. We are discussing about statement problems. Okay, this is also one of the statement problem and also very important problem, children. Okay, all statement problems are very important for the point of examination. So observe carefully. Okay, don't go anywhere. Follow it. See 18th question. The question is a spiral is made up of, there is a spiral like spring like, okay, spiral is made up of successive semicircles. Successive semicircle means continuous semicircle. A spiral is made up of continuous semicircles with centers alternatively at A and B. Okay, children. Yes. See, look at the figure here. This is the figure. Okay, what they are saying? There is a spiral. See, this is a spiral. It looks like a spiral. Okay, children. Okay, this spiral is made up of successive semicircle. This spiral alli number of semicircle ಗಳಿದೆ. ನೋಡಿ, see, here to here. See, this is one semicircle. Okay, and next, this is second semicircle and this is third semicircle. Here semicircle means half circle. Next, this is fourth semicircles. Continue like this, continues. Okay, children. Yes, and these semicircles have a centers. No, those centers are A and B alternatively. That means for the first semicircle A is the center. Okay, and for this second semicircle B is the center. For third again A. For third semicircle, this is the third semicircle now. Yes, for that again A is the center. For fourth semicircle B is the center. That means for there is a number of semicircles continuously. For each and every semicircle center is going to alternative. I'll repeat. For first semicircle, A is the center. To draw the semicircle, we have drawn by keeping A as center. For drawing the second semicircle, I am keeping B as a center. For third semicircle, again A is a center. For fourth semicircle, again B is a semicircle. B is a center. Like this centers goes on alternative. That is the question they are given. See, semicircles with centers alternatively at A and B. Clear? Okay, continue. Starting with center A means first semicircle should start with center A of radii 0.5 centimeter. Children, to draw the circle or semicircle, we need a radius, no? Okay, that's only they are given. For the first semicircle, starting semicircle with center A of radii, how much? 0.5 centimeter. See, look at the figure here. For the first semicircle, A is the center. For this semicircle, the radius will be, first radius will be 0.5 centimeter. You know radius? Radius means the line or the line segment drawn from center to its circumference, a point on the circumference. This is called radius. This radius belongs to first semicircle. That measurement will be how much? 0.5 centimeter. Clear? Next, 1 centimeter means next semicircle. Which is next semicircle? Second semicircle with center B. This is the second semicircle with center B. So this semicircle slightly bigger than the first semicircle now. That's why its radius again increases. How much? 1 centimeter. In the same way, for the radius of the third semicircle which from center A will be 1.5 centimeter and radius of the fourth semicircle will be 2 centimeter. That means for each and every semicircle the radii goes on increases. Starting from 0.5 centimeter, 1 centimeter, 1.5 centimeter, 2 centimeter and so on. Here half of centimeter goes on increases. Got it, children? Yes. They are given centers. Clear? As shown in the figure. Yes. We came to know about the figure. Okay. Next, what we need to find? what is the total length of such a spiral made of 13 consecutive semicircles? Children, here we need to find the total length of a spiral which is made of semicircles. How many semicircles? 13 semicircles. Got it, children? We need to find the total length of this spiral. Total length means how many semicircles we need to know here? 13 semicircles. I have drawn only few here and so on here. That means there are 13 semicircles. Got it, children? Yes, this is the question. Here we need to find the length of the spiral. Got it? Yes. See here. Okay. Yes, children. Let us solve here. So that means here we need to find the total length. Means length of each and every semicircle we have to know. Okay. The length of a semicircle is nothing but perimeter of a semicircle. Got it, children? You know very well there is a formula, that is the perimeter or circumference of a circle. See here, circumference is C, or we can represent circumference as perimeter of a circle, or we can represent that is length of a circle. Both are, all are one and the same. Okay. The formula is how much? 2 pi r. This is the formula is used to find the what? Circumference of a semicircle. That means the length of this total curved path. For this is the formula for complete circle. But here we are using semicircle. No, semicircle is half of the circle. Therefore, I will put divided by 2. What is, children? Therefore, 2 and 2 get cancelled, which is equal to pi r. So, pi r is the formula is used to find the length or perimeter or circumference of a semicircle. Got it, children? Yes, come let us do. Okay. So, here total length of a spiral is nothing but the total length of a 13 semicircles. No? Yes. See, let the length of semicircles are, okay, children? Yes, see here. I will take first the semicircle now. That is, I will put L1. That means length of first semicircle. The formula which is equal to, now only I told, that is called pi r. Clear? Yes. Which is equal to pi, keep as it is, and also you know the value of pi, that is 22 by 7. Okay, now just for the sake of simplicity I will put pi as it is. Now radius I will put here r1. Why? This is the radius for the first semicircle. You know very well what is the radius of the first semicircle. According to the question we came to know that 0.5 centimeter. Clear? Yes. Therefore pi into how much? 0.5 centimeter. Clear? Yes. Therefore which is equal to pi into 0.5, which gives 0.5 pi. This is what the length or the circumference of first semicircle. In the same way, I need to find one more. That is the length of second semicircle. Nothing but circumference of second semicircle, again which is equal to pi r. I will put here r2 because it is a representation like second semicircle, which is equal to, write pi as it is, and r2 is the radius of second is what? 1 centimeter. Pi into 1, which is equal to pi into 1, on multiplication we will get 1 pi. That is what? L2. Got it? Now again one more I am going to find, that is L3, which is equal to pi r3. Okay, which is equal to pi. What is the radius of third semicircle? Yes, 1.5. On multiplication we will get 1.5 pi. This is what? L3, length of third semicircle. This process continues. Okay, enough to find 2 to return. Okay. Now we need to find total length now. So this is the length of each and every semicircle. Now I am going to form a arithmetic progression by using the length or the circumference of each and every semicircle. Okay, I am consider this is the first semicircle, so I am consider this is the first term, second semicircle length, second term, third semicircle length, third term. Okay, see here. Therefore, the required arithmetic progression will be L1, comma L2, comma L3, so on, so on, so on. Up to how many semicircles are there? 13 semicircles. Okay. Therefore, to 13, I will put terms. 13 terms. Clear? Okay. What is the value of L1? That is 0.5 pi. First term. This is 1 pi. Second term. Next is 1.5 pi. Third term. Next, you may know that is 2 pi, 2.5. So I will continue like this. So on to how many? 13 terms. Children, this is our arithmetic progression. You know very well this is in AP itself, because for each and every succeeding terms, half is goes on increases. So is it? So we conclude this is an arithmetic progression. So here now I need to find the sum of these 13 terms. That gives the sum of 13 semicircles, nothing but the length of a spiral. Okay? Yes. Therefore, calculate the information A, which is equal to first term 0.5 pi. Clear? Next, D is equal to, let us check, no problem. That is A2 minus A1, which is equal to 1 pi minus 0.5 pi, which gives 0.5 pi itself. Is it clear? Is it? Yes, this is what? D. And next, N. So what is the number of terms here? What is? Yes, they are given here. There are 13 consecutive semicircle, means there are 13 semicircles are there. Means number of terms which is equal to 13. N is equal to 13. We need to find what? S13, which is equal to question mark. This S13 gives the total length of spiral. Got it, children? Yes. Now, by observing all these things, I came to know that S13 we have to use the Sn formula. Okay. Therefore, Sn, which is equal to n divided by 2 into 2a plus n minus 1 into d. Clear? Which is equal to S13 we need to find. That means n value is equal to 13. Here 13 divided by 2 into 2 into a value is how much? 0.5 pi. Clear? Plus n minus 1. N value here is 13. Therefore 13 minus 1 gives 12. Into d value is how much? D value again 0.5 pi. 0.5 pi is the d value. Clear? Close the bracket. So just have substituted the values. Okay. Next simplification, which is equal 13 by 2, write as it is. 13 divided by 2 into, multiply here, 2 into 0.5 pi. Very simple. 2 into 0.5 means what? Half. Half into 2 is nothing but 1. Is it? Therefore, 2 into 0.5 is nothing but 1 pi. On multiplication, I will get 1 pi. Okay. Plus, see here, 12 into 0.5 pi. So, pi is keep as it is. 12 into 0.5. 0.5 means half. Half into 12. Half of 12 is 6. Therefore, how much? 6 pi. Clear? Which is equal to 13 divided by 2 into 1 pi plus 6 pi, which gives 7 pi. Clear? Is it? Yes. Which is equal to, here 7 pi means 7 by 1. We need to multiply here. Okay. 13 into 7. Clear? Therefore, 13 sevens are how much? How much? 91. So, 13 sevens are 91 pi divided by 2. Got it? 13 sevens are 91, and 2 ones are 2. Numerator multiply to numerator, denominator multiply to denominator. Okay, I will write here. See, on multiplication, I will get like this. Therefore, S13, which is equal to numerator multiply to numerator, 13 sevens are how much? 91 pi divided by 2 ones are 2. Okay, now we'll simplify further here, which is equal to 91 divided by 2 into, I'll substitute the pi value, that is 22 divided by 7. Now we'll simplify this. From 2 we can divide 22, that is 2 ones are 2, 2 11s are. Am I correct? Yes. Next, from 7 we need to divide 91. 7 ones are 7. Here 7 ones are 7. 2 remains 21. 7 threes are. Clear? 7 threes are 21. What remains here? 13 into 11. Now we need to multiply, which is equal to 11 threes are 33. 3 carry. 11 ones are 11. 11 plus 3, 14. 143. That is what? Sum of 13, which is equal to, S13 is equal to 143. What does it mean, children? S13 means sum of 13 terms. Here terms are there. What are these things? These are the length of semicircles. That means 143. What is the unit they are given here? Centimeter. Therefore, 143 centimeter is the total length of spiral. Got it, children? Therefore, total length of a spiral is 143 centimeter. This is the solution, children. Got it? Very, very important problem, because to solve this problem we have used the geometrical formula, that is length of a semicircle. Keep in mind, length of a semicircle is pi r. In this concept we can find the solution. Okay, children? Fine. Hi, children. Now move on to the next problem, that is 19th problem. Okay, this is also statement problem, children. Okay. Yes, come look at the problem. 200 logs are stacked in the following manner. Yes, children, you look at the figure here. Here there are some logs are there. So they have arranged one above the other in the rows. Okay. See, if you observe the figure, if you observe the bottom row, the bottom line, there are 20 logs they have arranged. They have placed 20 logs. And also they are given in the question 20 logs in the bottom row. See, in the bottom, that is the full bottom row, there are 20 logs are there. Okay. That is the first row. We are considering from the bottom row is the first row. And the second, you observe the second row, there are 19 logs are arranged. That means one log is less when compared to the bottom row. That means first row. In the second row, that 19 logs have been arranged. That means one log is less. Okay. Let's see. 19 in the second row. In the same type, children, if you observe the third row, fourth row, fifth row, for each and every row, one log is goes on decreases if we move from bottom to top. Is it clear, children? Yes, see here, 18 in the next row and 17 in the their next row, 16 in the their next row. Like this, these logs have been arranged. You observe that figure, you understood? Okay, come, let us see what we have to find. We have to find, see, in how many rows are the 200 logs placed. That means, children, how many rows means first row, second row, third row means here we need to find number of rows. Okay, we have to find the number of rows. Here how many logs are there in total? In total they are given 200 logs are there. That means these 200 logs have to be placed one above the other in this manner. What is the manner? The arrangement in such a way that one log is less in each and every row from moving from bottom to top. So we need to find number of rows. Is it, children? Yes. See, by observing this question, we came to know that here we can form arithmetic progression. Okay, how? The bottom row, or we can say first row, we can consider as a first term. Second row is the second term. Third row is the third term. Okay, children. Okay, now I will form the arithmetic progression. Okay, see how many logs are there in the bottom row. That is nothing but first row. 20 logs. Yes, I will consider 20 is the first term, comma. In the second row, nothing but second term is how many logs are there? 19. There are 19. Next, 18. Next, 17, and so on, so on. In this manner, they have arranged. You observe this arithmetic progression. Is it then these terms are following the rules of arithmetic progression? Exactly, this follows because a2 minus a1, we are finding common difference. 19 minus 20 is equal to minus 1. 18 minus 9 is equal to minus 1. So this follows arithmetic progression. Okay, yes. So 20, 19, 18, 17, how many terms are there? That we have to find. See, in how many rows are the 200 logs placed? We need to find number of rows, nothing but number of terms. But they are given what? Total number of logs. So right here, which is equal to how much? 200. This is what? Sum of the terms. Okay, children? Yes. Come, let us do. I will collect the information. Here, A which is equal to 20, D which is equal to minus 1. I will write directly. Okay. And thereafter, what is this 200? 200 is considered as Sn which is equal to 200. Okay. Next, n is equal to question mark. Number of terms is equal to question mark. Okay. And one more thing we need to find here, and how many logs are in the top row. That means, children, if we arrange these 200 logs in such a manner, one or the other row will be the top. No, though in the top row, how many logs we can place? They are asking. If we consider the bottom row is the first row, we are counting from bottom to top. First row, second row, third row means top row will be the last row. Last row is nothing but here we can consider as the last term. So we need to find here an which is equal to question mark. Is it clear? Okay, now first we need to find the n value, then we will find the an value. Okay, so to find the n value, here Sn is there given. So now I am going to use the Sn formula. Okay, therefore Sn which is equal to n divided by 2, okay, into 2a plus n minus 1 into d. This is the formula. Okay, I'll substitute the values. Sn is equal to here 200 which is equal to n, we don't know. I will write as it is n by 2 into 2 into a value is 20 plus n value we don't know. D value is minus 1, put a bracket for minus 1, close the bracket. Now simplify this. See here 200, this divided by 2, if transferred to LHS it will become into 2, 200 into 2 which is equal to n into 2 into 20 is 40, clear. Next multiply minus 1 into n, that is minus n, minus 1 into minus 1, that is plus 1, close the bracket. 200 to 200 2s, that is 400 which is equal to n into within the bracket 40 plus 1, 41 minus n. Now 400 which is equal to multiply here for n into 40, multiply here n into 41, 41n minus n into n square. Now I will rearrange and write here n square transport to other side, minus n square will become plus n square. Plus 41 transpose means minus 41n. 400 is already here itself. Therefore, I will write plus 400 which is equal to 0. Now this looks like a trinomial. Now we need to find the factorization. Then we will get the value of n here. So you know the method how to factorize. Okay, first we need to multiply first term and last term, that is 400 and n square. On multiplication we will get here 400 n square. Sign is positive because plus into plus plus. We need to split this into two terms in such a way that these splitted terms on addition or on subtraction we should get minus 41. Okay, which are the terms? Think, children. Yes, children. Here we need to find the factors for 400. Okay, see, we can find like this 400. We go on finding the factors here. Okay, is it, children? So it will divide by 2 table and 4 table, no problem. I'll divide by 4 here. 4 ones are 4, 0, 0. Nothing but 100 fours are 400. Next, you can divide it by what? Again 4, no problem. 4 twos are, children, 8. 10 minus 8 means 2 remains. 2s are 20. 4 5s are 20 here. Yes, enough, children. This. See here. You multiply these two. 4 into 4, how much, children? 16 is the one number and other number is what? 25. So on multiplying 25 and 16, 100% we get 400. And also add these two, 25 and 16. How much? You will get 41. That means the terms are, okay, children, the terms are 25 and 16. Here n square is there, n and n here. Okay, and we need sign here. Is it? See here. In these two numbers, 25 is the bigger number. So put negative sign to the bigger term because we are added to get 41 means. So here also I will put minus. Then only we can add. Clear? Next. Therefore, that is n square. Instead of 41, minus 41n, I am going to write these two terms. That is minus 25n minus 16n. Instead of this, I am going to write these two. Check. Minus 25 minus 16 minus 41n. Okay. And remaining term is plus 400 which is equal to 0. Now, we need to take common in first two groups and second two groups. Very easy. Here n square and here n. Therefore, n is the common. The remaining terms in the bracket are n minus 25. Am I correct? Next, minus is there, minus. Here, children, again the same terms in the bracket has to come here also. So, I will put directly first, that is n minus 25. What term should we take common? Here 16n, n is inside, the 16 will be the common. Fix. Okay, 16 into n, 16n, minus into minus plus 1625 is a 400 which is equal to 0. Clear? Next step, again n minus 25 and minus 25 will take common, n minus 25. What remains other than n minus 25? Here n remains, here minus 16 remains which is equal to 0. Therefore, the 0 belongs to both the factors. Therefore, n minus 25 is equal to 0 once and n minus 16 is equal to 0 again. Therefore, n which is equal to 25 transpose means it will become plus 25. And next, n which is equal to plus 16. Clear, children? Yes. Here we got two n values. N means here natural numbers, counting numbers, both are counting itself. Now we have, I think both are correct or any one is correct. We have to check whether is correct. Which one is correct? We have to check among these two which one is correct. For looks like both are, looks like same. That means for looks like both are correct. Okay, children? Yes. Now I am trying to check the an value. Is it clear? Now we move on to the next one. That is what? an. So the formula of an is equal to a plus n minus 1 into d. Okay, I will check this by taking first n is equal to 25. You take here n is equal to 25. Okay, substitute here. An value we need to find. A value is 20 plus n value I am taken here 25 minus 1 is 24 into d value is how much? Minus 1. On simplification 20 plus into minus minus. Okay children, 24 ones are 24 which is equal to what's the answer? Minus 4. An which is equal to minus 4. An means what children here? The last term. What we are placing here? We are placing the logs. In the last term means it will come here. In the last term we place minus 4 logs. Is it meaningful? Plus 4 means 4 logs we are placing. Minus 4 means what? Negative value. So there is no meaning. That's why this an is wrong. That means this 25 is also wrong. Got it? Now check by taking n is equal to 16. Therefore n which is equal to 16. Okay. Again same thing. An is equal to a plus n minus 1 into d, which is a value 20 plus n means 16. 16 minus 1 15 into minus 1 is that d value, which is equal to 20 plus into minus minus 15 ones are 15, which is equal to 20 minus 15 is 5, positive 5. Therefore an is equal to 5. Is this n is equal to 5 is meaningful? Yes. N is what? Here n is what? Last term means in the top row how many logs can be placed? They are asking here. That means in the last row, nothing but in the figure, in the top row there are 5 logs can be placed. That means n is equal to 25 is wrong, n is 16 is correct. Okay children, so by observing this problem we came to know that if we arrange the logs in such manner, so there are how many rows are possible? There are 16 rows are possible. And what is the number of logs in the top row? There are 5 logs in the top row. Clear children? Yes, we can conclude here. Okay, therefore there are how many? 16 rows and 5 logs are placed in top row. This is the solution for this question. Have you understood? Fine. Yes children. Now we are in the last stage of this chapter children, that is 20th problem in the exercise 1.3. Okay children, this is also statement problem and it's not a problem children, it's like a game children. The question is like that. Okay, come let us read the question to understand what are the conditions. Okay, let's see. In a potato race, I told you that it's a game. Yes, in a potato race, a bucket is placed at the starting point, which is 5 meters from the first potato, and the other potatoes are placed 3 meters apart in the straight line. There are 10 potatoes in a line. Okay children, this is the initial stage of the problem. So let us understand one more time. So in a potato race, a bucket is placed at the starting point, which is 5 meters from the first potato. Okay children, see look here. So for easy understanding, just I will draw the rough diagram. Okay, see here is a bucket. Okay, here is a one bucket. Okay, this bucket and all the potatoes are in the same straight line. Am I correct? Okay. See here, The bucket is placed at the starting point. It is in a starting point in the race, which is, that means the bucket is 5 meters from the first potato. From the bucket, okay, from the bucket at a distance of, here, let us say here. Here is for, here is the first potato. The distance is how much? 5 meter from bucket to the first potato. And the other potatoes are placed 3 meter apart in a straight line here, and from first potato and here will be the second potato. The distance will be what? 3 meter. And for the third potato, the distance is 3 meter. For the fourth potato, the distance is 3 meter. For the next continuous all potatoes, the distance is like this, 3 meter. The thing is, the bucket is the starting point of the race. Bucket to first potato is 5 meter of distance, and next coming all continuous potatoes are 3 meter between them. Okay children, this is the preparation of the game. Now come to know the remaining part of the problem. See children, here there are 10 potatoes. We came to know here totally there are 10 potatoes. Okay, keep in your mind. A competitor starts from the bucket, picks up the nearest potato. A competitor starts its race from the bucket. Here, let us say this is the competitor, start from the bucket. He try to picks the first potato, nearest potato to the bucket means first potato. Okay, runs back with it and takes that potato, drops in the bucket, and again runs back and drop that potato in the bucket. Okay children, here let us think children, if a competitor starts from the bucket and that competitor has to travel 5 meter of distance to pick the potato and again runs back again 5 meter to drop within the bucket. That means to pick the first potato and put it in the bucket, that competitor has to travel 5 back again 5, totally 10 meters. Do you understand children this? Yes, to pick the first potato and put it in the bucket, the competitor has to travel 10 meters. Why 10 meters? Forward 5 meter and backward again 5 meter, totally 10 meter. For the first potato, the distance traveled by the competitor is how much? 10 meter. Okay, here is the 10 meter. Okay, next, continue the next. Runs back to take a bucket, runs back to pick the next potato again. After dropping the potato in the bucket, now the competitor again at the bucket. Now that competitor has to run to pick the second potato. See, this is the first potato already over, this is the second potato. So tell me children, what distance that competitor has to travel to pick the second potato? Exactly correct. Here is 5 meter of distance and here to here 3 meter of distance, totally 8 meters of distance has to travel to pick the potato. After picking, again runs back to drop that potato in the bucket. Again that competitor has to travel 8 meter to pick the potato, 8 meter, and back to put the potato in the bucket has to travel 8 meter, totally 8 plus 8, 16 meters. That means 16 meters of distance has to travel by the competitor to drop the second potato in the bucket. Clear? Yes. Now again the competitor is at the bucket. Now he or she, okay, try to take that potato and drop it in the bucket. Again that competitor has to run to reach the third potato. Tell me, to reach the third potato or to pick the third potato, how much distance has to travel? Very simple, 5 plus 3 plus 3. 5 plus 3 8, 8 plus 3 11, and again back to drop the potato in the bucket, again 11, 11 plus 11, 22 meters. Therefore 22 meters of distance has to travel by the competitor to drop the potato in the bucket. The same procedure continue, children, until all the 10 potatoes has to drop in the bucket. So how many potatoes are there? Up to 10 potatoes, nothing but I will write 10 terms. Okay, children. So this is the question. Drop in the bucket, runs back to pick the next potato, runs to the bucket to drop it, and she, oh here competitor is a girl, she continues in the same way until all the potatoes, means all the 10 potatoes are in the bucket. Now we need to find what is the total distance that competitor has to run. That means what is the total distance run by the competitor to drop all the 10 potatoes in the bucket. That means we need to find the SN here. Sum. Okay, children, we need to find SN. Clear? Yes, this is the arithmetic progression. Is it arithmetic progression? Yes, let us check. 16 minus 10, 6. 22 minus 16, 6. So, yes, these terms are in arithmetic progression. So, we can easily use the SN formula. That's why, children, arithmetic progression is very, very important to solve so many problems like this. Okay, come. I will collect the information. It is very, very familiar for you. No problem. We'll do once again. A is equal to 10. B which is equal to A2 minus A1. Nothing but 16 minus 10 which is equal to 6. D is equal to 6. Is it clear, children? Next, N. Number of terms. I will write 10 because there are 10 potatoes. So, number of terms will be 10. So, we need to find S10 which is equal to question mark. Sum of 10 terms. Clear? Yes. Now, therefore, we can use SN formula which is equal to N by 2 into 2A plus N minus 1 into D. Okay. Substitute the values, that is S10 which is equal to 10 divided by 2, N value is 10 into 2 into A value, first term is 10 plus N value, N is already we know 10, N minus 1 means 10 minus 1 is 9 into D value is how much? 6. Okay, which is equal to, we will simplify here, 2 1s are 2 5s are 5 into 2 10s are 20 plus 9 6s are how much? 54, which is equal to 5 into plus is there, we need to add 20 plus 54 is 74. Is it correct? Next is equal to just multiplication. 5 4s are 20, 2 will be carry, 5 7s are 35 plus 2 37. Therefore, S10 which is equal to how much? 370. What is this 370? It is in meters because the unit in the question they said that is in meters. Okay. Therefore, we can conclude that the competitor has to run totally 370 meters of distance to pick all the potatoes and drop it in the bucket. Okay, children. Yes, we will conclude here. Therefore, the competitor has to run how much? Has to run 370 meters of distance to complete the race. What is the race? Putting or dropping all the potatoes in the bucket is a race. So that's why that competitor has to run 370 meters of distance traveled totally to drop all the potatoes in the bucket. Okay, children, like this we can solve this problem. Okay, not only this problem, children, whatever the problem they can give, first your work is to read the problem once or twice, understand it, and if necessary you can convert that into a diagram for better understanding. Okay, after knowing everything you can collect the information and select a suitable formula, substitute the values, 100% you will get the solution, nothing but answer. You understand this one? Okay, fine children.